Good evening, everyone.
Hello.
My name is Nicoletta D'Angelo. I'm a PhD student in statistics, and I will be the session chair for the next two talks. So he's already a panelist. So the next speaker is Dinu Gherman, who will give a speech about XYZ, a new Python-friendly geospatial data management service. So please, Dinu, if you are ready, you can start.
I am ready. Thank you very much. Let me share my screen. Can everybody see it?
Yes, perfect.
Probably yes. Okay. Okay, thank you very much for having me, for inviting me to this online conference, my first conference after a couple of years. This is going to be about XYZ, and my name is Dino, by the way. I work for Here Technologies. The talk I'm giving is about XYZ, as I called it here, now Python-friendly geospatial data management service. Now Python-friendly means that I'm effectively going to talk more about a package which is called XYZ Spaces, which has been open sourced recently and which allows to use a technology stack we call XYZ from a very Python perspective or Pythonic point of view. So let me start. Well, here.com maybe is not known to everybody outside some circles. It is one of the location companies, maybe one of the oldest, dating back maybe to the 1980s or so, starting with a company named Navtech in the US. And it's very well known and established in the automotive and logistics industries, and it's growing outside of these industries as well. A vast amount of experience with all sorts of projects and packages and software. And as so often with such companies, every so often they come up with a new unified approach to do some of the things they have done so far in a more accessible, reusable manner maybe. And here I'm going to talk about XYZ, which is also pretty new, like it was released a couple of months ago, maybe less than 6 months ago. And the idea is to come up with something like, well, a unified, accessible, scalable, managed and open geo database. Some people call it a web service only because it has some RESTful APIs, which make it very nice to use. The main components of this are effectively something we call a hub, which is the core thing, kind of, the database itself, which is running on Postgres, etc. But I'm not going to talk about the infrastructure. And it provides a couple of nice RESTful APIs. One most important one for the hub itself. It comes with a CLI tool, and it has some online web interface, which I'm not going to talk much about here. So the features should be, or the goals also should be like, we wanted it to be open source. And it should be able to deal with large volumes of data in a cloud, maybe also in real time. Effectively, it does handle it in real time, so you can change data all the time and people can consume it and so on. And again, in this talk, I'm going to concentrate on the XYZ Spaces package, which makes it possible to use all this very nicely for Python programmers, data scientists, or data analysts. So the key concepts I mentioned already, the hub. The hub kind of organizes data into spaces, gives all these spaces IDs. Inside all these spaces, you will have geodata, which are called features, geometry data, you could say, or maybe records, even if you think of databases. And you can have tags and properties for all these features. Inside a space, of course, what can you do? You can create stuff, yeah, features. You can read them, you can list them, you can update them. You can also share features or delete them, of course. And you have some ways of getting meta information and statistics. And the features themselves, yes, again, I briefly mentioned it. Read, update, iterate, search. You can also cluster features using hex and quad bins, and it's kind of the operations you would expect from a RESTful API, of course. Search is very central, of course, because it's an important thing to do. You dump data into a database, you want to search for things, of course, something that you get back without you necessarily knowing what it will be. So you can search by ID, by tag, properties, bounding boxes, tiles, radius, or geometries. And the XYZ spaces for Python, official name of this, makes it very, very easy. And it's shortly abbreviated into XYZ spaces. So if you go to the GitHub page, it kind of looks like this. Well, we are proud of having many badges here, as you see. And we will see one of these examples here later a little bit in more detail. Okay, now the rest will be a mini tutorial that I had in mind, like it will be very interactive. And maybe it's going to be a little bit fast for everybody, but this tutorial is also in the repository on GitHub itself, so you can follow later. If you want to follow, you need to have a token for this XYZ system. For obtaining a token, you would go to the official here website, which is developer.here.com. And you can, as the button says, get started for free, and you create an account. And you need one special token then for the XYZ system. And you can do a lot with this alone. If you want to use a couple of pro features, you need to pay a little bit of money. It's like, I believe, 40 something bucks per month. Bucks meaning dollars or euros. Okay, so let's get started. We import a couple of features. What features? Packages, actually. One of them is named TurfPy, which is maybe also not so very familiar to many people here, because it's pretty new again, and it's implemented by a couple of colleagues of mine, and it will be presented in a separate talk tomorrow. So I recommend it very much. I use it, I like it. Okay, so much about that. Now you create kind of a client to the XYZ system, and you use this token, which comes here from the environment. And of course, what can you do first? You would look into what source, what kind of spaces are already available to you with this token. So in my case, this is not so many. And you can look at one of them. It has been created, of course, in this context. There is some meta information for this. You can create a new one, of course, which is what we are doing. And you have many features in here. Why is that? Because what I'm doing here, I get like a data set, which you will see immediately. Maybe let me show it to you instantly so it's immediately clear. It's like a data set showing all country borders worldwide. Actually, not quite all of them, but it's very useful even if they have only 180 from GitHub. So I use this very much. And this is what it looks like, as you could expect. Now, you can create, wait, this was not creating any space yet. So I only fetched the data. Yeah, this is a GeoJSON feature collection, which I have shown here in this map. Now what I do is I create a space in XYZ, giving it a title and a description. I can see like a little bit of meta information. This ID will be very important, so I fetch this here separately. And I can have some statistics about the space. This is not super interesting yet because there's nothing in, it's new. It has like 0 features in it, and the bounding box is not existing, no tags, nothing. Now let's add a couple of features, those that we have added or loaded so far, the GeoJSON feature collection. We're adding this into the space. And now let's see again the statistics. We have all of a sudden 180 features. The bounding box has changed and some other things have changed. And of course, you can iterate now also over these features. You can get access to the content inside of a space, which is like what you want to have, of course. And let's do this. We iterate here over the just created space. We iterate over all the features it has, and we display what we get back into a new map. And surprise, surprise, it will look exactly like the one before. But if you look closely into the data, it's not exactly the same. This is what we pulled out from the existing data sets. And there are a couple of properties, which is only the name of the countries. But if you look at what you got back from XYZ, you will have additional properties, which are stored in a namespace here. And there will be some tags, maybe. There will be an ID for the space where this feature belongs to, and maybe a few other things. And there are different ways of accessing your features, of course. And one of them is using like a very low-level interface, using methods or functions that implement the individual endpoints of the RESTful API. You can do it like this, but I would not recommend it because it's a little bit cumbersome. I would rather recommend to use a higher level class, which is a space class that repackages this functionality in a more intuitive way. So most of the time, I hope you don't have to know anything about the RESTful API. And this is the first feature from that space. It's the first, it's Afghanistan because, well, that's why. So this is what it looks like. And yeah, if you know it is Afghanistan, cool. You could also get multiple features. Okay, I'm not showing everything here now because it would take too much time. You could delete the spaces again, of course, but I don't want to do it because I want to reuse this later. And you can also update spaces. And of course, you can update the geometries, the features, but you can also update additional meta information, like you can add information to your features, like tags or parameters. Here I'm using tags only. I want to add a specific tag, which is named palindromish. And this means in this case only that I am looking at the names of the countries inside this space. And if the name starts and ends with the same letter, then I give it a tag, which is in this case palindromish, so kind of like a palindrome. Let's do that. And in the next cell here, I'm also looking now for all these features having this tag. And I'm getting back this short list here of countries. I would probably expect all of these to be here, like those with A at the beginning and at the end. Some other ones are a bit less expected, but they comply with my code that I have written before. Now, of course, you can search more things or in more different ways, and searching by bounding box is probably very popular. So you could define a bounding box here like I do for the southern hemisphere of the globe, and then search only for those features inside there. And this is what you would get. Of course, if you now, well, if you set the clipping to, I can't see that here nicely because it's covered by, okay, let's move this away. If I replace this with true, then the features will be clipped, and it looks like this. So you can also search by geometries. Like in this case, I'm taking Germany as an example. I get the one single feature for Germany or representing Germany, the borderline of Germany. And then what I'm doing is a search by geometry, which will give me all the features that somehow touch this one Germany feature, right? So what happens then is if I show this on a map immediately, I will get something like this. And what you see is basically Germany in the middle and then all the neighboring countries around it. And in school, you might learn that Germany in Western Europe has the most or the highest number of neighboring countries. 9 to be precise, which is quite a lot maybe. But let's look a little bit more into detail and look inside a bounding box here, which covers large parts of Europe. And you will get a list like this. All the numbers, all the countries covered. And then you could do the same thing again, but iterate it over all these individual features for each of these countries. So you come up with a data frame in this piece of code that will contain for each country the number of neighbors. And I'm showing only the top 5 here. And you will find out that Russia, in fact, has like many more than Germany, maybe expected or not. Of course, it extends into Asian parts of the world, so that's why. And if you want to have more details, then you have this bar chart, which gives you all the glory details, like Russia here to the left with the most, and Iceland being an island with no neighbors, of course. Now, you can also search for tags and parameters. We have already done for tags, but I want to show some more things with parameters, and I want to switch to a different data set as well. And in this case, this will be the data set which was published by Microsoft, and it contains all the US building footprints, which is quite a lot, like 125 million or so. And this is one of the public data sets that you can find in what we call the data hub, which is here's implementation, public implementation of XYZ. So this is the commercial offer kind of that is running on the net and that you can use and that you can get that token for that I mentioned at the beginning. So this is one such big space in that data hub. And I can show you briefly, very briefly, like this what we call here Studio, which is the online interface. And I expected now to see a different data set, but doesn't matter. So I didn't want to show you so much about this. In fact, let's go back. So if I want to get access to this space inside our data hub or an XYZ hub for that matter, there is a function doing exactly this to make it more easy, so you don't have to remember the ID. And then I get access or a handle to the space, and I can look inside a little bit into the metadata, and I see like it has 137 million features, and it's pretty big. If you look at the number of the bytes, yeah, about more than 200 gigabytes. Now, let's look at a very specific place there, because everybody's looking there nowadays to the White House. And if you happen to know the postal code of the White House, then it's very easy to get that. And here what you do is you search for a tag, all the features that have this tag set. And then what you will get is only this one, because that's the postal code of the White House. And you can look at the feature. You will see some more properties and tags with some overlay, and in this case, a high degree of overlay or overlap, sorry, but doesn't have to be the case. And if you compare this with the official data set that you would get from Microsoft, and I copy pasted it here, it's not very nice to see, but believe me that if you look at the properties, there are no additional properties you would get from the Microsoft data set, but here inside our data hub offer, we have geocoded all of these buildings, and that means you can work with some more data that you didn't have before, like streets and addresses and postcodes and building numbers, whatever. Now let's get quickly some data from this data set. So I'm looking here for 1,000 building footprints from the city of Washington, which happens to be where the White House is, as you know. But I'm using the parameter here, like I'm specifically asking for a parameter, not a tag anymore. And the difference between tags and parameters is like parameters are something you already know, like key value pairs, where tags are only simple strings. So if you want to show this on a map, it would look maybe like this. And the order of what exactly you see here, which 1,000 building footprints these are, is not well defined. You should take it as undefined. And you can do other kinds of searches. You can do something that is called spatial search. And you would say you give the parameters the latitude, longitude of the White House, and then you search in the neighborhood of this center, 2,000 meters radius, everything you can get, all the features, and then you put it on a map and it looks like this. But let's do a little bit more. Let's use the TurfPy package that I mentioned at the beginning. And this has a function named area, where you can find out the surface area of the building on the ground, the footprint, so to say. And we're looking at all these features that we got above. And we'll find out that the smallest has like 17 square meters, and the biggest one has many more. And I have this color scale here, and I want to show this on a map again. So what this is showing all the buildings in this neighborhood with a color code showing you the size of the building footprint. So you have the small ones in a very pale color, but the big ones here, and the biggest one is this one, have a stronger color. And this happens to be a convention center in Washington, DC. So what you see is the area here encoded in that map. Now, I maybe don't want to go to the GitHub page again, because the time maybe is not sufficient. But on the GitHub page in the repository, there's a nice example of this, where in fact you don't visualize the area of the buildings, but you visualize the number of the houses in the respective streets. So I know many people are obsessed with postcodes, but I thought, let's try something more granular, more fine-grained. And this is what I came up. Maybe if I still have that link here. Yeah, if you look at this, this is the example you will see in the README. And it's much more interactive. It encodes the building numbers and has a nice histogram plot here as well. It's like a little bit more of code, but it's more interesting probably to look at. So one more interesting feature, which is a pro feature, is like you can cluster data. So for this, I need to use a different token. So let's do this. And I will create a new space, which I have done here already. I called it a cluster space, again, with some title. And I'm adding like only one feature we have seen already, which is named, well, it's representing Afghanistan, the country of Afghanistan. If you look at this again, you have seen it before, still looks the same. But let's do some hex clustering. And one thing you can do is you can fill like polygons like this with hex cells. And in this case, maybe this is not super exciting and interesting, but I still wanted to show you what it looks like. And it would look like this, basically. This is like very low level 0. But as you increase the level, you will get increasingly more fine-grained hex cells. So this is clearly not super useful, yeah, but let's do something different. Let's look at a real data set, which is like many people also work with, all the airports you can find in the world. So I'm converting this CSV file into a data frame here first. And then I'm filtering the data frame a little bit, so I concentrate only on the European airports and exclude the Russian ones because I don't want to extend so much into the Asian parts. Otherwise, it's getting too big for a map. Then I save it again into a CSV file, and I create an empty map first. And I create, or I add, in fact, first the CSV features from these European airports from the CSV file into our XYZ space. These are about maybe 7,000 or so. Now, once this has happened, I'm able to run a function or a feature which is called clustering. And this will cluster the airport locations in a certain resolution I'm indicating here. And I can create, like what you have seen before, create first a color map to make this nicely visible and put it on a map like this. And now what you get is a map with hex cells. And these look like what they do. Right, so you have some different concentrations of airports here in Europe. And if you would overlap this with the existing or the real locations of all these airports, it would become much more cluttered for you and me, at least. So I want to stop here with presenting so many more features because there's not enough time for doing this. But to clean up here the data, okay, I don't need to do that, but I want to say what I have not shown. Like I haven't shown how to search by tiles, for example, which is also doable. Tiles are like these squarish things on Mercator maps. I haven't shown you how to use schema validation. Whenever you add some data to your spaces, you can validate that. I haven't shown you like virtual spaces, what that is. Basically, this is some kind of groups of spaces that you can work with together. So you can apply changes and then it will be saved back into the respective single spaces again. I haven't shown you activity logs, which is kind of something where you can track changes in these spaces, basically data sets, yes, stored in your spaces. And I haven't shown you rule-based tags, which means like you can not only add single tags that you know already, but you can auto add them given some constraints or some conditions. All these features are also pro features, so you need a special version of this here developer account. Now the conclusions I want to draw is so far, and the takeaways you should have from this presentation is first of all about XYZ, meaning that you should remember it as an open source geospatial cloud database or service. And as I mentioned in between, it is the technology stack and the foundation of what HERE offers as a commercial service named HERE Data Hub. You don't need to pay for many features of this. There's a free plan allowing you to do a lot of things, and you don't also need even a credit card to get started. So what you store in these XYZ hubs or in the data hub are geodata features, more or less, or I would say essentially this is GeoJSON that you store there. And you can manage all these features at scale, and you can filter and search them nicely. And most important for you here, this all loves Python since a couple of months because we released only recently a package which is called XYZ Spaces, available via pip and Conda Forge. And we would be super glad for you to use this and engage with XYZ and try it out and give feedback. There are a couple of links here at the bottom I'm still around here for questions right now, later today, and also tomorrow. That's so much from my side. Please ask me anything.
Okay, thank you so much, Dinu. I guess we have time for just one question. I read here. I don't know if you can read it. I will read it out loud. Terence says a very interesting talk. So quick question. How did you extract those building houses polygons from Washington city image? Is there a function for that, or?
How did I extract which data exactly?
Building houses polygons.
I'm not sure I understood. Which polygons?
It says building houses. So
Right. Those from the Microsoft.
The one next, yeah.
You mean how we entered it into a here space, a here XYZ space? That's what you mean?
Yes, I don't know. It says just that the question is
well, maybe we can sort this out in detail during the session on Discord.
Okay.
It's a huge database. It is available. I mean, what Microsoft published is available on GitHub. I have the link in this presentation. So I don't know how we extracted this into, or how we added it into our data hub. I haven't done it, but we have done more than that, because it's not the naked data you would get from Microsoft. We also geocoded all that data, so it actually contains more information than what you would get from Microsoft.
Okay, thank you so much.
You're welcome, my pleasure.
Okay, so I will look for the next speaker.